Okay, let's look at example 2. Example 2. Show that the limit of 5x minus 3, x approaches 1, is equal to 2. So how do we show that? Using the definition. So what are we given right now? We're given that x of 0 is equal to 1. Our function f of x is a line. Our limit point is 2. Given any epsilon greater than 0, we are to find delta so that if for all x's, even if x is not equal to 1, as long as the x is within delta distance around 1, that is, whenever x minus 1 is less than delta, then f of x is within epsilon distance away from 2. F of x minus L is less than epsilon. For this particular case, we have 5x minus 3 minus 2 is less than epsilon. But what is this? If we rewrite that, that is just equal to 5x minus 5 less than epsilon. Pull out the 5 and we have x minus 1 less than epsilon. We divide through by 5, so simply saying that x minus 1 is less than epsilon over 5. So what do you think is a good choice for our delta? Look how this is similar, or they're what we wanted for a distance away from 1. So if we choose delta to be equal to epsilon over 5, then that would mean f of x minus L is less than epsilon. And right there, here, notice that if the delta is epsilon over 5 away from 1, then it is bounded by this open interval. 1 minus epsilon over 5, and to the right side of 1 is 1 plus epsilon over 5. That is this width, that means this width has a length of delta. For this particular horizontal strip, we can find a vertical strip for which all the y values differ from 2 within epsilon distance. So let's see how we did that. Notice that to find the delta, we work our way backwards, like what we did a while ago. I'm just going to repeat it so that we can see exactly what we did. We started out with our epsilon inequality. Epsilon inequality. What is the epsilon inequality? F of x minus L less than epsilon. So remember, our y, or f of x, is 5x minus 3 minus 2. And that is equal to, from the previous slide, 5x minus 5. Pull out the 5, and that is less than epsilon. Divide through by 5 will give us this inequality. X minus 1 is less than epsilon over 5. And that's why I said there we take delta to be equal to epsilon over 5, so that if given epsilon greater than 0, for all x's, and possibly x not necessarily equal to 1, if x minus 1 is less than epsilon over 5, then we see that f of x minus L, in this case 5x minus 3 minus 2, continuing on like we did, it's like going backwards. We go 5x minus 5, which is equal to 5x minus 1. Okay, since we have chosen delta to be equal to epsilon over 5, it's less than 5 times epsilon over 5 equal to epsilon. So what exactly we did? We have proven that if our choice of delta is equal to epsilon over 5, then for all x's such that this inequality holds, then y minus L, an absolute value, is less than epsilon. We have proven, therefore, that, okay, this 3 dots means, therefore, the limit of 5x minus 3 as x approaches 1 is equal to 2.